Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of zombie processes in Linux and how to deal with them. This tutorial will cover everything from understanding what zombie processes are, why they occur, how to identify them, and the limited ways to eliminate them, along with practical code examples. Understanding zombie processes. A zombie process, also known as a defunct process, is a process that has completed its execution but its entry still remains in the process table. Let's break down what that means. 1. Process lifecycle *. A typical process goes through several stages: creation, execution, and termination. 2. Process table *. The operating system, specifically the kernel, maintains a process table, which is a data structure that keeps track of all running processes. Each process has a unique process ID, PID. This table is essential for the OS to manage processes, allocate resources, and keep them isolated. 3. Termination and exit status *. When a process finishes its work, it calls the exit system call, or something equivalent in its programming language. The exit call signals to the kernel that the process is done. The process can also return an exit status code, which indicates whether the process completed successfully or encountered an error. This exit status can be a number, usually 0 for success, non-zero for failure. 4. The role of the parent process *. Crucially, after a child process exits, the parent process needs to reap the child. Reaping means the parent process uses the wait system call, or a similar function, to retrieve the child's exit status and release the resources associated with the child's entry in the process table. 5. The zombie state *. A zombie process is in a state where it has terminated, the code has finished executing, but its entry still exists in the process table because the parent process hasn't reaped it. The process isn't actually running anymore, it's just a placeholder. The kernel holds onto the information in the process table entry so that the parent can later retrieve the exit status. The process is waiting to be reaped. Why zombie processes occur? The primary reason for zombie processes is that the parent process is not properly waiting for its child processes to terminate. Here are common scenarios that lead to this. Parent process doesn't call wait. The parent process might simply be coded without any wait calls at all. This is often a bug in the program. Parent process crashes or terminates unexpectedly. If the parent process terminates before it can reap its children, the children become orphaned. In this case, the init process, PID1, adopts the orphaned processes. Init is designed to call wait on its children. So, typically, orphan zombie processes are short-lived. However, if init somehow fails to reap the process, which is rare, but possible under resource exhaustion or system errors, the zombie can persist. Parent process is too busy. The parent process might be performing other tasks and not have the time or resources to call wait promptly. This can result in temporary zombie processes, but they should eventually be reaped. Parent-child communication issues. Sometimes, synchronization problems between parent and child processes can lead to a situation where the parent process doesn't realize the child has terminated. Identifying zombie processes. You can use standard Linux tools to identify zombie processes. 1. PS command *. The PS, process status, command is your go-to tool. The L, long listing, option is particularly useful. Look for processes with a state code of Z. The stat column will show Z for a zombie process. You'll also see defunct in the CMD column. You can refine the PS command further. 2 top and HDOP commands asterisk. Top and HDOP are interactive process monitors. While they don't directly highlight zombies in a separate column, you can observe the process list for entries marked as defunct. HDOP is generally preferred as it provides a more visually appealing and interactive interface. 3/proc file system asterisk. The /proc file system provides a detailed view of process information. Each process has a directory under /proc named after its PID, example /proc/1234. You can examine the stat file within these directories to get the process state. This is more complicated and less convenient than using PS. Example, creating a zombie process, deliberately. Let's create a simple C program that spawns a child process, which then exits, leaving a zombie. This is for demonstration purposes only. You shouldn't intentionally create zombie processes in production code. Steps to compile and run asterisk. 1. Save the code as zombie_example.c. 2. Compile the code, gcc zombie_example.co zombie_example. 3. Run the code, /zombie_example. 4. While the program is running, during the 60-second sleep, open another terminal and use PSL or PS auxiliary grep Z to observe the zombie process. You'll see the child process with a state of Z and defunct. Note the PID and PPID, parent PID. 5. After 60 seconds, the parent process finishes, and the zombie is eventually reaped by init, if the system is working correctly. How to fix the code, prevent zombies. The solution is to have the parent process call wait, or waitpid, to reap the child. Here's the corrected version of the code. Explanation of the wait, family of functions. Asterisk wait, in status, asterisk waits for any child process to terminate. If a child has already terminated, wait, returns immediately. The status argument is a pointer to an integer where the exit status of the child is stored. If you don't care about the exit status, you can pass null. Asterisk waitpid, PID_TPID, int status, int options, asterisk. This is the more flexible function. It allows you to wait for a specific child process, identified by its PID, or for any child process. It also allows you to specify options. Asterisk PID 0, wait for the child with the specified PID. Asterisk PID == 0, wait for any child process in the same process group as the calling process. Asterisk PID-1, wait for any child process whose process group ID is equal to the absolute value of PID. Asterisk PID == 1, wait for any child process. This is equivalent to wait. The options argument allows you to control the behavior of waitpid. Common options. Asterisk 0, blocks until a child process terminates. Asterisk unahang, returns immediately if no child has terminated. If no child has terminated, it returns 0. Otherwise, it returns the PID of the child. This is useful for non-blocking waiting. Asterisk traced, also return if a child has stopped, but not terminated, because of a signal. Asterisk macros for interpreting the status asterisk. The status argument passed to wait, or waitpid, is an integer that encodes information about how the child process terminated. You use macros to extract this information. Asterisk wifexited, status, returns true if the child process terminated normally, i.e., by calling exit, or returning from main. Asterisk weakset status, status, if wifexited, status, is true, This macro returns the exit status value that the child process passed to exit. Asterisk with signaled status returns true if the child process was terminated by a signal, example kill, sigsegv. Asterisk termsig status, if with signaled status is true, this macro returns the number of the signal that caused the child to terminate. Eliminating existing zombie processes. This is where things get tricky. You cannot directly kill a zombie process using kill or other process management tools. A zombie process is already dead, it's just waiting to be reaped. The only way to eliminate a zombie process is to get its parent process to call wait, or to terminate the parent process. 1. Fix the parent process asterisk. The best long-term solution is to identify the parent process and fix its code to properly call wait, or waitbid. This prevents future zombies from being created. This is the only proper solution in a production environment. 2. Terminate the parent process asterisk. If you can't modify the parent process, example it's a third-party application, you can terminate the parent process. When the parent process dies, init will adopt the orphaned child processes and will eventually reap the zombie. However, terminating the parent might have unintended consequences and should be done with caution. Asterisk identify the parent PID, PPID use PSL or PSF to find the PPID of the zombie process. Asterisk terminate the parent asterisk use kill PPID, try a sigterm signal first, then kill if necessary. Be absolutely certain you're killing the correct process. Important asterisk terminating the parent process is a drastic measure and should only be done if you understand the implications. It might cause data loss or other issues. 3. A very desperate measure, reboot the system. If all else fails, rebooting the system will clear the process table and eliminate all zombie processes. This is obviously a last resort. Why you can't kill a zombie? It's essential to understand why you can't kill a zombie. Asterisk it's not running any code asterisk the zombie process isn't executing instructions. It's just an entry in the process table. There's no code to signal. Asterisk the kernel manages it asterisk the zombie process is managed by the kernel. User space tools, like kill, can only interact with running processes. Asterisk it's waiting for the parent asterisk the zombie is waiting for the parent process to acknowledge its termination and retrieve its exit status. Important considerations asterisk. Asterisk too many zombies asterisk while a few zombie processes are generally harmless, a large number of zombies can indicate a serious problem. If the process table becomes full of zombies, it can prevent new processes from being created, potentially causing the system to become unusable. Monitor your system for excessive zombie processes. Asterisk resource exhaustion asterisk in rare cases, if the parent process is extremely slow to reap children and the system generates a huge number of child processes that exit very quickly, you could theoretically exhaust some resources, like process IDs. This is unlikely on modern systems with large process ID spaces, but it's worth keeping in mind. Asterisk debugging asterisk zombie processes are a sign of a bug in the parent process. Debug the parent process to identify why it's not calling wait. Use tools like GDB, GNU Debugger, to step through the code and examine the execution flow. Consider using logging to track when child processes are created and expected to terminate. Summary. Zombie processes are a symptom of a parent process not properly waiting for its children. The only definitive solution is to fix the parent process's code. Terminating the parent is a workaround, but it can have unintended consequences. Avoid creating zombie processes in your own code by always reaping child processes using wait, or waitbid. Monitoring for excessive zombies is important for system health.